All right, so we're going to continue to do some work with identifying end behavior from polynomials today. But I want to introduce a new form to you. So up until this point, yesterday, we saw polynomials that were in standard form. So standard form, that's what we just saw with all of those warm-up problems today. It looks like terms that are separated by plus and minus signs. Another thing that we talked about yesterday with standard form is we want our exponents to be in decreasing or in descending numerical order. So the highest exponent in front, the smaller exponents go behind it. And so when we have a polynomial in standard form, we already know that the degree is simply the highest exponent. And we also know that the leading coefficient is the number in front of the term with the highest exponent. So for example, with the polynomial that's written here, the highest exponent that we see is 3, so that would be our degree. Degree is 3. And the leading coefficient, the number out in front of that term, is 2. Now let's take a look over at the other side of the chart. It's also possible for us to have polynomials in factored form. We've actually seen this many times before in the context of quadratics. We did a ton of work factoring back in chapter 4. And so the format of this, there's some things that should be familiar to us. Factored form always involves parentheses. And so we're going to see factors in parentheses that are being multiplied together. Now here's one possible situation for how that can look. Notice how we have an x squared on the outside of our parenthesis. Because it's touching this first parenthesis, it means that it's being multiplied. And then we've got the quantity x minus 1 raised up to the third, which really means x minus 1 times x minus 1 times x minus 1. That's just a shorter way to write that. And then that's being multiplied by x plus 4 at the end. And so if we wanted to find the degree of something that's in factored form, we're going to need to go about it a different way. Because we want to think about, well, if we were to multiply the whole thing out, what would be the highest exponent if it was in standard form? And so we want to think about, well, how many x's are involved that are being multiplied together here? And so that x squared in the very front really represents 2 x's being multiplied together. So that's like an x times x. Right here, this piece in the middle, that quantity x minus 1 to the third, we already said that that's going to be x minus 1 multiplied by itself 3 times. Well, without having to actually do that multiplication, we can see that that x on the inside part there will be multiplied by itself 3 times. And then we have an extra x represented here at the very end. So if I were to actually go back and put some colors in here to see where the x's are coming from that we're thinking about being multiplied together, it would look something like this. Whoops. Blue color for the end. There we go. Now the thing is that if we truly were to multiply this whole thing out, it would have several terms. There would be lots of plus and minus signs. But really, to get the degree, we only need to know what the first term is. It actually doesn't matter what any of the other terms are that are behind it, which is why we don't truly need to multiply it out. We just need to know how many x's there are. And so in this case, we see represented, we have 6 x's being multiplied together. Well, that's going to be represented by x to the power of 6. And we don't have anything else out in front of that x squared. Like at the very, very beginning, there's really just an invisible 1 in front. So we can assume that that invisible 1 will stay in front of the x to the 6th part. If we were truly multiplying it all out, we would have all of those terms behind it. But we don't need to worry about that in this case. And so this polynomial would have a degree of 6. because that's what the highest exponent would have been if we turned it into standard form. And so the way to get this a little bit quicker, more easily, is that when your polynomial is in factored form, if you want to find the degree, all you're going to do is add the exponents that you see. So going back to the very beginning of this, if we just added together 2 plus 3, and this is an invisible 1 at the very end, 2 plus 3 plus 1, that is going to equal that degree of 6. Now we want to be very careful with this method and make sure that we are only using it if it's factored form, if you see parentheses. What we don't want to do is get confused and start to look back at standard form and try to start adding those exponents together. We would never do that if it's in standard form. It's always the highest exponent. The only reason we're doing it over here is because we want to see what that highest exponent would have been if we turned it into standard. Now, the leading coefficient in this case in factored form, it's just a number that's in the very front of the first factor. So whatever is your first factor that's in the list, so like in this case for us, it was x squared. And that's why we talked about that invisible 1 in the very front. It's possible that that could be a different number. Like it could have been a 3 in that position. It could have been like a 2 in that position. It could have been a negative 1 in that position. Whatever that is, that's still going to be our leading coefficient. All right, so I want to give you just a chance to try this out. And so there's a little table right down below. There's just 4 functions given to you. And I want to give you a few minutes to fill in as much of this as you can. So you're going to start by identifying if it's in standard form or factored form. Then I want you to go ahead and identify the degree and the leading coefficient. And then I want you to list the end behavior. All right, so we're going to come back together. Let's just take a look here and check our answers. So it looks like just the first one and the last one were in standard form. So neither of those had parentheses. And so because they were just in standard form, we're just looking for the highest exponent to figure out the degree. Leading coefficient is the number out in front. We're going to use our rules right over here to get our end behavior. And then the 2 in the middle, so number 2 and number 3, since they both had parentheses, those were ones that were both in factored form. So we want to be really careful when we're getting our degree. We want to think about what the highest exponent would be if the pieces were all the way multiplied out. Now I want to point out on the second one that we're not at all thinking about an exponent attached to this 2 in the very front. That 2 is actually just the leading coefficient. Notice how there's no x attached to it, and so we don't need to worry about that in terms of figuring out the degree. We're just going to think about adding the exponents here that we see, 3 plus 3, and then we have an invisible 1 exponent attached to the parenthesis at the end, and so that's going to give us a degree of 7. So notice how that leading coefficient was the 2 in the very front, and that gives us an end behavior of down, up. When we take a look, though, at number 3, we are going to think about the exponent attached to the x in the very, very front because it is an x. That's ultimately what we're wanting to do. We want to know how many x's are being multiplied together. And we have a bunch of invisible 1 exponents. They were not originally shown to us, and so that means that it's really a 1. When we add those together, our degree is 3. Now, the leading coefficient refers to what's in the very front of the whole thing, which we also don't see anything there, so we can assume that it's just a positive 1 in the very front. That also has an end behavior that is down, up. Does anybody have any questions here at this point? Okay. In your note package, I want you to go ahead and turn over to page 4. And this is a sideways page, so feel free to go ahead and turn your packet off to the side. I have some additional practice questions that I'm going to have you work through. You can work together with your partner, you can talk together with your group, or you can work through it individually. We'll have a chance to kind of come back together on all of these in just a few minutes. This is going to give you a little bit more practice on that difference between standard form and factored form.